Okay, it's 3:05 and we're going to get started here. Again, my name is Lavoska Barton. I'm with Blue Telcom, and today we have Josh Phillips with us. Josh is with Phoenix Broadband, and Josh is going to share with us their monitoring solution. So let me, um, Josh, I'm going to make you the presenter.
All right.
Okay. And let's see. Okay. So did you just get that, Josh? Are you good or?
I see where I'm the presenter now. I'm just looking for the button to be able to share my screen here.
Okay.
I see share my webcam. You can't see my screen, can you?
Um, Not yet. I can't.
Yeah, I don't have a button for sharing my screen anywhere. Do you know where that might be?
Um, Let me see here.
The
Um,
only
let
options I
me
have are to share my webcam.
let me do this. Let me make me. I just made me the presenter. Um, and okay, so let me try it. Let me try it again.
Okay.
Um, I've got you down here 3 times, so I'm not sure which one is which.
Yeah,
Um,
it should be the one that has the green microphone. I'm not sure. I just
okay,
saw another one pop in of me. I haven't clicked on anything.
okay, so I just clicked on it. So how about now, Josh?
I still see my
There,
webcam.
I see your webcam.
Yeah, I have nothing to share. I have nothing to share a screen though.
Oh boy. Um,
And we've used GoToMeeting before, and usually the option's right next to the microphone, but I do not have
it
that option.
says,
Oh, it looks like the presenter is on the wrong one.
okay, let me try. Let me try another one here. Um, Let me try this one. How's that?
There we go. Now I have options.
Okay, great. All right, good. Yep, I see your screen in it's in yep, you're up,
Okay,
Josh.
perfect.
So
All right, there we go. Well, good afternoon. My name is Josh Phillips with Phoenix Broadband Technologies. I'm the national sales manager. Most of my concentrations and focuses are within the cable industry and utility markets. So I have a lot of customers within that realm. As I go through this, I know there's not really anybody else on here right now that is in speaking mode, but if you have any questions or anything you'd like me to elaborate on, or if you just want to sync up later, Lavoska has my contact information. Feel free to reach out to him and get that, and we can sync up later and hit on whatever you need.
yeah, Josh, I'll probably um open the lines after your presentation for questions.
Got it. All right, so
Yep.
I'm not going to go through a full PowerPoint here. I know really no one really has the patience for something like that. So I'm going to kind of briefly go through this, and then I'll go right into our web pages, and so you can kind of see how everything connects, and then how it kind of works from the web GUI side. So again, I'm with Phoenix Broadband Technologies, and we have a focus in critical facilities monitoring. A lot of what we do is with battery monitoring, but we can do other things and integrate other devices that are not from Phoenix Broadband into our devices. So like whether it's air quality sensors or air controls, like air conditioning or even lighting, all that can be brought into our controller and be controlled. So we do a lot more than just battery monitoring, but our focus is in battery monitoring. And PBT was founded in 2004, and it's been privately held. We are not technically located in Philadelphia. We're actually about 45 minutes north of Philly, but no one really knows where Hatfield is, so we just say we're in Philly. All of our products are designed and manufactured in the USA. So down at the bottom right, you can see our facility. I can walk out of my office and walk right into manufacturing, engineering, development, testing, you name it, everything's under one roof here. So we're not sending anything out of country to get produced and then waiting on long lead times. Everything's done right here in house. So our markets, some of the big players in the cable industry, at least, Comcast, Charter, Cox Communications, Mediacom, and then utility market, we're with Southern and a few others. We have some customers up in Canada. I won't go through all of our customers, but we are pretty heavily embedded in most markets across the US and Canada. We're working with a lot of the bigger players in most of these markets too. And I always say if you need some kind of vetting process done where you're looking for somebody from another company to kind of vet who we are, what we do, or heck, even what I do, we do have great contacts there that will be happy to vet for what we've done for them and how reliable we've been. The system in general is pretty simple, right? So we have a controller that goes into the facility, and that is consider it the brains of the operation, right? It runs a Linux operating system, and it's all inclusive. What I mean by all inclusive is there's not another device that needs to be hooked up to this in order for you to view the data that's in there. It runs a web server into it, so as soon as it has a static IP address, or it doesn't really need a static, as soon as it has an IP address in it, you can navigate to that IP address in your web browser and pull up the web page to see all the readings in the controller. And I will show that web page here in a moment, but I wanted you to see the physical layout of the controller. So we have our controller, and then attached to that, we have battery sensors down here that are connected to batteries. So that is all connected with standard Cat5 cabling. We don't use any kind of specific cabling or harnesses that you'd have to reach out and get quotes for. We use standard Cat5 cabling, and usually within these facilities, there's a box of it sitting somewhere. So if a string has to be moved or a controller has to be moved, you don't need to wait on somebody to give you a wiring harness. That can all just be done with just your standard Cat5. So in here, we have our batteries. So as you can see, there's one battery sensor per battery or jar, and then they are daisy chained together and ran back to the controller. That's the typical layout. So you have one battery sensor per battery. They're daisy chained with a standard 1-foot Cat5 cable is what we ship with. And then the last battery sensor in the chain just has a Cat5 or Cat6 cable that goes back to one of the inputs on the controller. In this diagram, we're showing what's called our SC Mini XC controller. So it's our mini controller. It has 2 inputs for battery strings, so it can do a maximum of 48 batteries. Our full-fledged SC4 controller can do up to 240 battery sensors. And the reason we have 2 is that depending on what a customer has, they may only have a couple strings of 12-volt batteries for their 48-volt plant. So they don't have a whole lot of batteries. They don't really have a need for a controller that's fully fledged like the SC4. They're looking for something more cost effective for what they can get. So the SC Mini XC has all the features of the SC4, just doesn't have the capacity of the SC4. And then other things we have on here connected is over on the right-hand side, we have some of our RIMs and ROMs for controlling. Like I said, we can integrate other devices. One of the ones that's typical within the utility industry, we have some large aperture discharge current sensors that we integrate so that we can grab that higher 300, 400, sometimes even 1,000 amps, and bring that into the web page and see what those batteries are doing during discharge.
So hey Josh, quick question, and you may, if you get into this later, that's fine. But how is electrolyte level monitoring handled?
Great question. So yeah, so all of our battery sensors have the ability to be integrated with electrolyte level sensors. We make our own. So you would still have a battery sensor per battery, just like you see here. But additionally, if it is let's say you reach out and you say, hey, I need a system for some flooded cells, the battery sensors are going to look almost identical for those batteries. But what the difference is going to be, there's going to be a little connector on there that will allow our ELS sensors to plug into the battery sensor. So it's an add-on to the battery sensor is what it is, our ELS sensor. So you have a battery sensor, and you have our ELS sensor that plugs into that battery sensor, and it adheres right to the glass of the jar. And it's using I forget exactly what the chemical compound is. It's not a chemical adhesion that we're using. It's a rubber binding that we're using that's it doesn't hurt the casing. Some folks get really worried about adhering anything to the glass of these things. It's been vetted through Alpha, C&D, and East Penn to not cause any damage to the jars. So it is perfectly safe to adhere on there. So it's as well as, so as you see, the battery sensors are daisy chained, the ELS sensors are daisy chained to those battery sensors. So you have one battery sensor, one ELS sensor per jar.
Okay.
Does that answer your question?
Yes, it does. Thanks.
And they're small. I may have a picture of one in here. I don't have one in this presentation, but what I can do, Lavaska, is send you a separate email. I do have some slides on that somewhere. I'd have to dig them up and send it over so you can see what it looks like. I've also got one in my office I can just take a picture of and send it over to you as well. But it's very straightforward.
Okay, great. Thanks.
So I won't get down into the weeds. I can send out some data sheets on our controllers, but some of the things that our SC4 controller does. Again, the SC Mini XC has the same feature set as the SC4. It just has less inputs for battery sensors. So they're going to do SNMP, V1, V2C, NV3, DNP3. They now do Modbus, so they can get that information out a variety of ways. And a DNP3 is more common in utility space. Cable industries tend to do more with SNMP, and then other industries kind of use a variation of both or Modbus. So we can probably communicate or integrate with whatever infrastructure they already have. So again, I won't get too far down here, but if there is a specific integration, like let's say they have some software that they're already using that they want to get this information in, typically we ask a few questions to kind of vet what it is, and more than likely we've already dealt with it before, and we'll either come up with a solution or say, hey, we've already done that work. We can get pulled right into that software and get you the data in whatever way it needs. So I'm going to get away from this PowerPoint here and kind of get into the actual web page so you can see what all this is doing, because a lot of this sounds great, but it doesn't really make a whole lot of sense till you can see how it's being represented. So let me go back to this one slide real fast. Again, we have our controller, standard Cat5 cabling go into our different devices that hook up to it. We call it a master-slave architecture. If you've ever dealt with computers in the past, that's reminiscent of some old terminology in computers. So we have our controller, then we have everything that brings that data into the controller.
Okay, great.
So here is the web page, if you can see that.
Yes, you're good.
Okay. So this is the web page. I have one for our SC4 and for our XC pulled up here. I have them both pulled up just so you can see. They are basically the same equipment, right? There's not much difference between the number of inputs, or besides the number of inputs, I should say. And I want to make a caveat here. I had mentioned this to Lavaska before we got started, but these are on external IPs in our office. Feel free to log into these and take a look. But we have our engineers in-house right now. Some of them are from Colorado, so these are being beat up on and being brought down more often than normal. So there may be some things there that stop working momentarily while they're being beat up. I know they're having a meeting right now going into the same controller. So with that said, on the left-hand side here, this is the strings and batteries. Everything that's connected to the controller is going to be on the left-hand side here. So I'm going to go down to the ones that aren't in purple. Purple means something's been disconnected, so somebody's unplugged something. But I'm going to go down to port 6 here. And so we can see all of the batteries that are connected to port 6 on the SC4. So our SC4 has 6 ports for battery sensors versus just 2 for the SC Mini XC. Each one of the inputs on an SC4 can do 40 battery sensors. So let's say a 40 jar UPS, that can all be handled from one input on the controller. So one controller could do 6 UPS streams. So while we're in here, we can see, okay, here's the voltage on each jar plugged in here. Here's the S is an ohmic reading, so that's the admittance measurement that our battery sensor is taking. And the 0% next to it is the delta, and that delta is between what that admittance measurement is now for where that battery is and where it should have been when it was new. So the reason you're seeing 0 in here is because there is no admittance measurement set for what this battery should be when it's new, because these aren't actually on batteries in our office, they're on simulation boards. But if this was out in the field, and let's say on a brand new battery, you should be seeing 0%, right? So if we know what a battery should be reading when it's new, and we have our battery monitoring system on there when it's new, it should be 0%. And then as those readings are taken, day by day, month by month, you'll see it go from 0 to -1%, till -40%. And that leads me into kind of how we do monitoring. So we're taking these readings, a lot of data that gets recorded in here. And the way we calculate a bad battery is there's a bunch of different ways of doing it, but the most simplistic way of doing it is looking at that delta and how bad or how far that battery is degraded from when it was new. So as a battery ages out, that number of 0% will get down to like -40, -45 as it starts getting to what we would consider time to replace it. Different companies take different stances on when they want a battery to be replaced. Some of them, want to say, hey, I want to know when the battery gets to -40% because I want to let my guys know, hey, start budgeting and forecasting to get this battery replaced, in the next 6 months to a year. Some don't want to know until it's time to get that battery out of there today and it's a break fix. And we try to get them away from that mindset, but a lot of them don't want to think about batteries until it's actually time to get it out of there. So depending on how you have your alarm set, this is all user definable in here. So you can set your alarms up, minors and majors, on the upper and lower limits of any value you see in here, however you want them to be set up. So whether it's, voltage, ohmic, temperature, string voltage, all that can be alarmed within here, however you see fit. And we get down to how that's defined, after you said, hey, we want to have a discussion on getting battery monitoring and what your system can do. We'll have a discussion based around, okay, well, how do you want to, be notified of when we would say this battery needs to be replaced? Do you want it to be, what do you want your percentages to be? That's a conversation that's done. Every customer is a little bit different. There are some default values in here. So if I'll log in here, for instance, and I'll show you what I'm talking about. Anywhere where you see all I did was right click on it and click on view settings. Anywhere where you see a little blue icon with a white bell, that is an alarm that can be set within the controller. So I'm going to unlock this. And let's go to admittance change. That's what we're talking about with the delta. So I mentioned we have 4. So we have 2 uppers and 2 lower limits we can set for every alarm within the controller. So we have some defaults in here at -20 and -40%. It's pretty straightforward. You can enable or disable them from here, and you can change them. So let's say we want our minor, get a yellow minor alarm set out at -30%, and then a major set at -40. Just click in there, and we can set it to, right now it's set to this cell, but we can push it out to the entire string too with the click of a button. But I'm not going to make any changes from in here, but that's how you set your alarms in here or change them around. And there's a dead band here. The dead band is, let's say you have a cell that's at -39%, for instance, and it's getting between -39 and -40%. You don't really want it sending an alarm and then sending a clear alarm back and forth every time it takes a new reading if it's on the hairy edge. So we put a dead band that says, hey, once it hits that threshold, it won't come back out of that status until it clears it by 5% there. And that's user definable too. So that's the way the web page are. There's some other great information here. You have some charts that it kind of rotates through. It's going to go blank every once in a while because there is a bunch of devices that are unplugged right now from this controller. So you'll see some stuff that just reads 0. For instance, right now it just showed one. But it represents them so you can kind of see any outliers from in this page. But what we really like getting into is the data that all of this is behind. So it's one thing to get an alarm, right, when a battery hits a certain threshold, but one of the great things about our controller is the amount of data that it gathers. So anything you plug into the controller, any value that it has, all that is recorded to a log file. In those log files, you can go through and track data that is, anywhere from, a day old to 10 years old, depending on how long the equipment has been on there and recording data. So the SC4 controller comes with a 16 gigabyte flash drive that is in the front of the controller that is removable. So you can download data. You can also download data right from this web page. You can download it via FTP. Like I said, you can just pull the flash drive out and plug it into your computer and open up these text files. So just CSV files, but you'll have all of the data that this controller has ever gathered stored in one spot every day. Now, during a discharge, it does that a little bit differently. It records data, I think upwards of 20 times, 30 times a minute. So you have a lot more data in there to look through during a discharge, so you can really get down and see how the batteries have performed. But typically, if there's no discharge and the controller is in what's considered a normal status, you would have 1 log entry per day. And I'll show you what one of those looks like. Again, this is going to be on a development unit here, so there's going to be some junk in here. I already know that.
Yeah.
But I'm going to go ahead and grab one. I'll grab it off the string 6. I know that's the one we were just looking at. And this is what you see when you first open up a log file. And these will be as big or as small, as they need to be, depending on how long the equipment's been out, because we're recording that daily. You can set the controller to record hourly too. I typically don't recommend that, just because there's not a whole lot changes in a battery from hour to hour. Now, if you're tracking an older battery that you're worried about, then yeah, maybe you want to switch it over to hourly just for that time, just to see how it's performing as it's on its way out, or if you're worried about it. But typically I say, leave it on the default for every 24 hours. It'll make a log entry in here, and we can see, here, June 9th through July 18th in here, we can see what our voltages have been on every jar every single day. We can see the ohmic measurements, the admittance measurements in here every day, and the temperature readings every day. Those are the 3 things that our battery sensors are grabbing. They're grabbing the temperature, voltage, and ohmic daily. And then you'll have some other stuff in here, like what the flow current was during that time. If there was a discharge, it would tell you here. Right now it's NA because there hasn't been any, and what the ripple current is. We are recording ripple current as well if you have our flow current sensor. So I mentioned we integrate some discharge sensors, but we have our own flow current sensor that measures down to a single milliamp changes down to 10 milliamps. So it's highly accurate for flow current. So that'll be recorded in here as well, so you can see how these batteries and how the string has been functioning every day.
Perfect.
Any questions about the log files, Lavaska?
No, that's great, Josh. Let's do this because we're running a little bit short on time. This was excellent. I do have a couple of questions for you.
Absolutely.
So, Josh, there are a number of battery monitoring companies out there. What distinguishes Phoenix Broadband over the others?
Great question. So I can give you the generic answer, which is, normally what we find is we're cheaper than everybody else, which is usually a pretty big point for most customers, right? They've looked around. Today, we found most of our customers that come to us, they've already done most of their homework, right? Or a lot of times they've already tried out another vendor and they're unhappy with what they've gotten and how the system operates. I'm dealing with a customer out of North Carolina right now, for instance, that is making the switch, and their reason is the system they had before was overcomplicated. After I showed them how we do things, a lot of times what we find is if you've already dealt with a company and then you look at what we're doing, you think that we're doing something wrong. And I mean that in the best way possible.
Right.
We don't use wiring harnesses. We don't like to make things complicated. Everything is, you look at our sensor and you look at our controller and the cabling we give you, it makes sense. You can open up that box and say, okay, I know how this works. This makes sense. Perfect. I can do this. We do have a training course to show you how to do everything else. It looks simple, but there is more to it. So it comes down to simplicity, cost, but the reality is we give you a lot more tools than our competitors tend to give you, and we don't charge you for those tools, right? We don't nickel and dime you for software fees. I know one of our competitors, for instance, you get the web page or you get the equipment, but you wouldn't get this web page, for instance, with them. You have to pay them a licensing fee yearly in order to get access to the web page. Otherwise, you just get access to the raw data. We don't like doing that kind of stuff. We try to give you everything up front, and we use all open source protocols too. So we're not using something that's specific only to PBT and you need special software to do that. No, we can integrate with pretty much anything, and everything's open.
Awesome.
And I can go even further with this, but those are the typical pain points that I run into with my customers. And like I said, a lot of them nowadays have already done their research. They already know what a monitoring system is and what it should be. It comes down to, do I get what I need out of it? How hard is it to get that data out of it and what I need out of it? And maintenance, what does that look like? Is it something where my guy can go in there and actually get into the system, or does he have to have special software loaded onto a laptop to even see what the data is and what's it look like? And we make all that very simple and straightforward. And I guess the fourth thing that I will toot our own horn, We've been told time and time again that we have rock stars for tech support. You don't get put into a call queue or anything. You call in, you talk to somebody right away. We are Eastern time zone, so it does assume you're calling between 8 and 5, Monday through Friday,
Right.
on Eastern time zone. But Frank and his team are fantastic over here, and I've never heard anything bad about any of our techs.
Excellent. Well, great, Josh. Any closing thoughts?
No, what I always tell people is, write down the IP address, take a look at what we're doing here, and reach out to me, right? Or reach out to you and pass it on to me, however you want to handle it. Every customer is a little bit different on what they want, what they're looking for. So I don't really lay a blanket on it. I say, let's talk about it and see, what your pain points are and how we can help you with that. But don't be afraid to reach out and get some more information. There's a plethora of it over on our side. We have no problem getting you whatever you need.
Excellent. Josh, thank you. Thank you so much. Thank you for participating. And again, we'll be sharing this presentation via YouTube. So hopefully we'll generate some interest as a result.
Sounds good. Thanks for having me.
Okay. Yep, you bet. So guys, I'm going to take a little bit of time here and I am going to show my screen, and I'm going to go over one of our other products. And we've got a couple of minutes, so I'll go quickly through these, but we've got a product called WeWe. It is a full duplex radio communications system, and it's a pretty well advanced technology in that arena. The full duplex system allows full duplex voice communications between two, not only two, but other WeWe devices. It operates in two modes. One, where the person is in a master mode and everybody's listening in a slave mode, or you can do two-way simultaneous communications among 6 people. So the question might be, why would Blue Telcom be interested in a product like this and have it as part of their portfolio? Well, the reason is we believe communications is advancing, and we focus our technology solutions on reducing cost, improving efficiencies, etc. And we feel that a full duplex radio communication system in a campus environment can help communications between groups of people in that environment. So let me show you a little bit more about this system. It operates on available different frequency bands, but also operates on a 2.4 gigahertz band. It has noise suppression technology. It supports Bluetooth, and the units are very small. And as you see here below, there are 4 available units, handheld devices that can be used, and the 5th box there is a repeater box for the system. So the next slide, it's two-way communications. I mentioned the Bluetooth. The repeater development has been completed. It also has noise canceling technology in the more recent handsets. Here are some of the industries that this device can be used in, and is used in around the globe. It's used in voice communications for sports, as a tour guide, also in broadcast mode. It's used in hospitals. It's also used in simultaneous interpretation, and my focus is certainly not only the service industry, but industrial sites, any kind of campus site it can be used in. So that's very quick, given the limited time we normally have on these on these webinars. Please reach out to me if you want to hear more. You'll also see additional information on this application in future posts and newsletters. So so I'm going to close at this point, as we usually do, with 35 minutes in our webinar. I want to thank you all for attending, and please reach out to us if any of our products will be helpful to you. And again, Josh, thank you so much for participating, and we appreciate everybody's attendance, and have a good day.
Of course, anytime. Thank you.
All right, bye.